Hello all, welcome to my YouTube channel all about VLSI. Hope you are all doing good. Good evening everyone. I hope my voice is audible and my screen is visible, right? So I hope my screen is visible and my voice is audible. Okay. Good evening everyone. So in this session, we are going to start with inheritance in SystemVerilog. It is a very important topic in our SystemVerilog programming. Okay, so we are going to discuss about that inheritance in SystemVerilog. Okay, so before going to start this session, make sure you have subscribed to our YouTube channel all about VLSI, and if you like this video, please do like, share, and subscribe. Okay, yeah. So let's start our session. So let me open my presentation. I hope my screen is also visible. Right. So today's agenda is inheritance in SystemVerilog. Okay. Today's agenda is inheritance in SystemVerilog. So what is this? Sorry. So what is this inheritance? So inheritance is a core concept of object-oriented programming (OOP), and SystemVerilog with its OOP support, okay, and incorporates this feature to allow new classes to derive properties and methods from existing ones. Inheritance helps in code reuse, creating modular designs, and improving the scalability of the test bench. So basically, in the inheritance, we are going to derive the properties and the methods from the parent class to the child class. So there are basically two types of classes in inheritance. Okay, so there are basically two type of classes in inheritance. One is called parent class, one is called parent class, and second type of class is called child class, and second type of class is called child class. Okay, one is called parent class and another is called child class. Okay, so the class which is deriving the properties, okay, the class which is deriving the properties from is called as a child class. That is, it derives the properties from the parent class. Okay, and the class which has all the properties and from which other classes are being derived is called parent class. Okay, so the basically two classes, parent class and child class. Okay, the classes which are getting inherited from are called child classes, and the class from which all the classes are getting inherited is called as a parent class. So basically, in this type of inheritance, this helps us to achieve code reuse, and it also helps us to create modular designs and improving the scalability of the test benches. So this is the use case of our inheritance. Okay, so as discussed, we have two type of classes. One is base class, or it is also known as parent class. Okay, one is known as base class or parent class, and another type class or child class. It is known as derived class or child class. So we have two names for this. One is called base class or parent class, and another is called derived class or child class. Okay, so the base class or the parent class is a class from which the properties and methods are inherited. Okay, so the base class or the parent class is the class from which the properties and methods are inherited. Okay, this parent class will consist all the properties and methods, and from which the child class will take these properties. Whereas the derived class or the child class is the class that inherits the base class and can add new properties and methods or override the existing ones. So basically, this derived class or child class is going to inherit or take the properties from the parent class, and it can also add some more new properties or change the methods which are present in the parent class. Okay, this I will show here. So let's say if we have a class called class parent underscore class, and let's say it has three properties: int a, int b. Let's say it has only two properties and a method. Okay, function, let's say display, function display. It will display something. let's say the printf the value of a is 0. Like this, it is printing something. Okay, the value of a is equal to 0. End function, end function, and end function and end class. So like this, we have some parent class. Okay, so in this parent class, or it is also called as a base class. Parent class is also called as a base class. So a parent class or a base class is having two properties. One is a and another is b. It is having some set of properties. It is having some set of properties, as well as it is having a method called display, which will display the values. Okay, printf the value of a is 0. It is displaying. So it is having one method, as well as it is having some properties. Okay, this parent class is having some properties, as well as it is having some methods. Now, how to create a child class? So basically, how to create a child class? So creating a child class from a base class or a parent class, I will write it here. So creating a child class from parent class or base class is known as inheritance. Okay, so how to derive it? So we will use the keyword extend. Okay, we use the keyword extend to derive a child class from a parent class. So we use the keyword. What we are going to use? We are going to use a keyword called extend. Okay, so using this keyword extend, we are going to derive a child class from a parent class. So how we are going to derive it? So if we want to create a child class of a particular parent class, we will use class child. Let's say it is child underscore class extends parent underscore class. So this is how we are going to extend. Or we are going to derive a child class from a parent class. So this step means we are going to, that is the child class what we have declared, the child class what we have declared is going to access all the properties. So child class which we have declared now, or which we have derived now, is going to access all the properties and methods which are present in the parent class. So child class can actually access these properties as well as methods which are present in this parent class. So this is how the derived classes access the methods and properties from the parent class. So this is parent class. Parent class is having in our particular example, it is having three properties, right? A, B and C. So the child class which is derived from this parent class can have the access to this property A, and it also have the access to property B, and if it wants, it can also modify this method. Okay, so the child class which is being derived from our parent class, it can also modify this method display. Okay, how it is going to modify everything we are going to see. So this is what base class and derived classes or parent class or child class looks like. Okay, and they are created using the keyword extend. Right, now single inheritance. So SystemVerilog supports single inheritance where a derived class inherits from only one base class. Okay, so a child class can only inherit from a single base class. So this is implemented using the keyword extends. Okay, this is achieved by keyword extend. This we have already seen. So let's see the syntax for inheritance, how we are going to inherit a child class or a derived class from a base class. Okay, so this also we have seen, but we will see once again. So we have declared a class called base class, and we have declared a property. Data is a property here, and it is also consisting of a method called display, which is of type void. Okay, function void display. Okay, and we are displaying something $display. Sorry, here I think I have written printf. Sorry, it is not printf, it is $display. Okay, $display base class data is %d comma data. So we are displaying something in the base class. So function void display $display base class data is percentage d comma data. Okay, and we are ending the function. So we have a method in this. We have a method which is declared inside this base class. Okay, and we have a property which is declared inside this base class. Okay, now what we are doing, we are basically deriving a child class or a derived class from this base class. What is meant by deriving? What is meant by extending? We are basically, this derived class can access the property data which is present in the base class, and some more properties to it. Okay, that is, here it can also add some more properties. That is, here in this case we are adding extra underscore data. So we are creating int extra derived class. So this derived class becomes the child, and we are creating one. And now here we are creating one more function called function void show. Okay, function void show, and $display derived class extra data is percentage d comma extra data. So we are displaying the value of extra data. Okay, we are displaying the value of extra data, and we are ending the class and function. Okay, this is how we are going to create a derived class or the child class from a base class or a parent class. Okay, now, so in this particular example, what we have done, we have created a base class which has only a single property data and a method called display, and derived class which inherits data and display from base class and adds a new property extra underscore data and a method show. So basically this derived class inherits the property called data which is present in the parent class, and display is also method which is inherited from the parent class to the derived class. Okay, so this property as well as method are inherited from the parent class to the derived class, as well as we are adding some more properties which are called as here extra data, and we are also adding one more wait a minute. Yeah, and we are also adding one more property called show. So this is how we are inheriting the property and method, as well as we are adding the method called show. Okay, now how to access the properties and methods. So with inheritance, the derived class has access to both its properties and those of the base class. So this we have already seen. So when we inherit a derived class from a base class, we can have the access to the properties and the methods of the base class. So the child class or the derived class has the access to parent class or base class. So it has the access to parent class or base class. Child class has an access to properties of parent class, as well as, or it has the access to methods which are present in the base class. Okay, so how we are going to access those properties and methods which are present in the parent class, how the child class is going to access those properties or methods, now we will see. Okay, so let's take an example. Module inheritance underscore example, initial begin derived class derived underscore object is equal to new. So in an module, what we are writing, so we are writing the child class name, which is derived underscore class. In this example, derived underscore class is the class name, that is a child class name, which is being extended from the parent class, and we are creating a handle called derived underscore object. Okay, and we are creating the object for this by using the keyword new. Okay, by using the keyword new, we are creating the object. Now what we are doing, so we have two classes. What we are doing, so we have two classes. One is called, here in this example we can see, one is called base underscore class, one is called base underscore class, this one is called base underscore class. This is the parent class, or you can say base class. It is a parent class or base class. It is having a property called data, int data. This is a property which we are having in the base class. And we have a child class which is called derived underscore class. Derived underscore class. It is a child class which is being derived from our base class. Okay, and it is having a property called in this we can see this is having a property called extra underscore data. Okay, I'll write it here. It is having a property called extra underscore data. Okay, now what we are doing in the module, we are creating the handle for the derived class. We are creating the handle for the derived class called derived underscore object, and we are creating the object for this by using the keyword new. So handle, by using this handle, what we are doing, we are going to access the data which is present in the base class, which is present in the base class. So what we are doing, derived underscore object dot data, and we are modifying it value to some random value, derived underscore object dot data. So this data is not present in the derived class, it is present in the base class. It is present in the base class. Since the derived class is a child class of this base class, so it can access the property which is present in this particular class. So that's why we can access the data or the property which is present in the base class using the child class handle. So I will write it here. So due to inheritance, what we are going to achieve, we are going to access parent class property with child class handle. That is what we are going to achieve. So with the help of inheritance, we are going to achieve parent class property with the help of child class handle. We can achieve we can access parent class property with the help of child class handle. That is what we are doing here. So derived underscore object dot data is equal to 10, and derived underscore object dot extra underscore data is equal to 20. Extra underscore data is a property of derived underscore class only. Here we can observe extra underscore data is a property of derived underscore class only. So with the help of this handle only, we can access the data, this property, right? So derived underscore, in the module we can see derived underscore object dot extra underscore data. This in our previous sessions also we have seen this. Okay, with the help of this class handle, we can access that particular property which is present inside that class. Okay, this we have already seen in our previous sessions also, but this is new thing. What we are seeing in the second step is new for us. So what we are doing, with the help of the child class handle, we are accessing the data of the parent class handle, the property of the parent class handle. That is new here. Okay, I hope it is clear. So with the help of inheritance, we are achieving this particular thing. Now, if you observe, the display is the method of parent class. The display is present in the parent class. Here, a function called display is present in the parent class or base class. Okay, this display method is accessed with the help of child class handle. So derived underscore object dot display. So calling the base class method with child class handle. We are calling the display method with the help of child class, and show is the child class method only. So we can access it with the child class handle only. It's not new for us, but this fourth step is new for us. So we are accessing the parent class object with the help of child class handle. So this is new for us. So this is how we are going to access the parent class properties as well as parent class methods with the help of child class handles. Okay, so this is achieved due to the inheritance. Okay. I hope it is clear. Okay, now let's move forward. Now, overriding methods in SystemVerilog. How to override methods in SystemVerilog? So a derived class can override a method from its base class. So a derived class can override a method in base class. To override a method, the derived class defines a method with the same name as the method in the base class. Okay, so basically what is overriding? Instead of using the parent class method, we are going to use a child class method. That is called overriding. So how to achieve overriding the parent class method, child class method should. Okay, so then only we can able to achieve overriding. Okay, what is overriding? Let's say suppose if we have class called base class, it is a, now we have a method called display, function void display. We have a method called display and we are displaying base class display method. Okay, we are displaying something and we are ending the function and ending the class. Now we have a class called derived underscore class, which is extends base class, so which is extending from base class. So this derived underscore class becomes child class or derived class. Okay, so class derived underscore class, with the help of the keyword extends, we are going to extend the class from base class. So this derived class can access the properties or the methods which are, so derived class can access the properties or methods which are present in the base class, that we have already seen in our previous slide. Here what is new is both the base class as well as the child class is having the same method name, which is called as display, and the child class is having the same method name, which is called as display, is having the same name, which is called as display. But in the content is different in this base class and child class. So in the base class it is written base class display method, but in the child class it is written derived class display method, derived class display method. Okay, now but the method names in the base class and the child class are different. If you observe clearly, the method names are same. The method names are same. Okay, now so what happens in the module? If you write module tb initial begin, if you create the child class handle derived underscore object h1, which is equal to new, I'm creating the object for my handle h1. Okay, now I'm going to access the method which is present in the child class h1 dot. Okay, so I'm going to access the method which is present in the child class h1 dot display. Okay, so if you write h1 dot display, obviously the child class method will only displayed. If you write h1 dot display, so the compiler will consider only the child class method. This is called overriding. If the display, if the method names are different, that let's say here if we have display underscore 2, and if we write h1 dot display, the method which is present in the derived class will be printed, and if we write h1 dot display underscore 2, then the method which is present in the base class will be called. Okay, we can differentiate it clearly, but here we are performing overriding. Okay, so to perform overriding, what we should do, both the method names which is present in the base class and child class should be the same. Okay, both the method names should be the same, so that if we call the method h1 dot display, then only the child class method is being printed, no parent class method is printed. Here only the child class method is being printed. This is what overriding means. Okay, so if we call the method name, then obviously the derived class method is being printed. Okay, so this is called the concept of overriding. Okay, this is how we are going to override a particular method. Okay, do remember this. This is a very important topic actually. Okay, do remember this. Now, next coming to the keyword super. So we have discussed the keyword called this. Okay, this refers to the local scope. Okay, here super refers to the scope of parent class. Okay, super refers to the parent class properties or methods. So to access the base class version of an overridden method, SystemVerilog provides a super keyword. This allows calling the base class method from within the derived class method. So super refers to the base class or parent class. So we are referring to base class or parent class. So if a super keyword is used in a derived class, so if a derived class consists a keyword called super, if a derived class consists a keyword called super dot something, so it is referring to the base class or parent class. So that is referring to the base class or parent class. Okay. So if a derived class consists of a keyword super dot something, so then what it means, it is referring to the parent class or the base class. Okay, that is what super refers to. Okay, now we'll see an example. Let's say, suppose if we have a class called base underscore class, and function void display. Okay, function void display. We have the same method in the base class, as well as same method name in the base class, and as well as child class. Here also we have the same methods. But here, if you observe, $display base class display method, we are display end function and end class. And in the child class, if you observe, that is the derived class, if you observe, we are using the super dot display, and we are displaying $display derived class display method. So equal to new, and if we call h1 dot display, calling the method h1 dot display, then what method calling the method h1 dot display? Then what method will it print? Will it print the base class or child class method? Obviously, it will print the derived class method only. It will call the derived class method only. So what is present in this derived class? What it is present? Super dot display is present, and we have derived class. We have one display statement. Okay. So what happens? So here there is written super dot display. So this will call the display method which is present in the base class. So finally, what will be our output? Our output will be base class display method, and we also get derived class display method. So we will get two display statements called base class display method and derived class display method. So this is how we are going to print the two display. We are going to the same name. But in the previous case, if you observe, if we are calling the display method with the hand h1 dot display method with the hand h1 dot display, if we are calling it, we are only getting